The topic that we are going to learn in this lecture is real depth and apparent depth, which is part of refraction. Real depth and apparent depth. Which is part of refraction. Now, let us suppose there is a water tank and this is water. And a coin is sunk in the water tank. This is the coin. And now you are looking at this coin from somewhere here. You are looking at this coin from somewhere here. To see the coin, when can you see the coin actually? When can you see the coin? When you are able to see any object. You can see any object when light rays from that object comes and falls on your eye. Okay. So for that, in a ray diagram, we have to draw at least two light rays to make you understand. Let one of the light ray which is coming from the object be this. I am choosing this light ray. Okay. This is one of the light ray. This light ray does not bend here. What is the reason? Because I have taught you in the previous class that normal incident ray, this is normal incident ray because it is making 90 degrees here at the surface. Normal incident ray does not bend to any other direction, but it goes straight. That is the reason why I am drawing this way. And let me take another light ray which is coming from this object, and let me draw a normal here at the surface. This is the normal. Okay. Now, because the light ray is traveling from denser medium to rarer medium, light ray bends away from the normal. Light ray bends away from the normal, and now if we project this light ray backwards, this light ray meets this light ray here. So the image actually appears to be situated here. So actually this object or this coin is here, which is called the real depth. Let it be D. We are measuring the real depth from the surface. You have to remember this carefully. You have to remember this very carefully, that we are measuring this small d from surface. Okay. Now this is the real depth. Actually the coin is here, but because of the phenomenon of refraction, this coin is appearing here, which is somewhat nearer to the surface. Okay. Now let this distance, this apparent depth be d dash. Let this apparent depth be d dash. Now, one more thing I want to tell you is here the apparent depth seems to be smaller than real depth, but in some other cases apparent depth may be larger. It depends upon where the observer is and where the object is, and etc. Never ever get confused that apparent depth is always small. It depends on different cases. Now, let the refractive index of the medium from where the light is coming, the light is coming from this medium into this medium. This is water and this is maybe air or any other medium. The light ray is coming from this medium. So if the light ray is coming from this medium, let it be N2. And if the light ray is going to this medium, let it be N1. Okay. Remember this light ray, the medium from where the light ray is coming, we will take it as N2, and the medium where the light ray is going, we will take it as N1. Now we have a relation between N1, N2, D and D dash, which is equal to N2 by N1 is equal to D by D dash. N2 is the refractive index of medium where the light is coming from. N1 is the refractive index of medium where the light is going to. Okay, you have to remember that. And D dash are the distances measured from the surface boundary. Okay, boundary. Let me just rub it. D is real depth. D is real depth. D dash is apparent depth. Now let us derive this formula. This is the relation and we have to remember this formula, and let me derive it now. Let me draw the diagram one more time. This is the water surface. So this is water surface and the object is here. Sorry. Okay, now this is N2, this is the medium N1. Okay, now this is the incident ray here on the boundary. So this angle is I. I am taking this angle as I, and this angle is R because this is refracted angle. This angle is R, this angle is I. Now these two rays are parallel to each other. So if this is angle I, this is also going to be angle I, and this is angle R, refracted ray. Okay, this is refracted ray, angle R. So these two lines are parallel. So if this is R, this is also angle R, and let this distance be x. Now according to Snell's law, refractive index of this medium into sine of this angle, refractive index of this medium into sine of this angle is equal to refractive index of this medium into sine of this angle, that is R. This is according to Snell's law. N2 sin I is equal to N1 sin R. Now one of the important thing that I want to mention is these two rays are para-axial rays, which means both of these rays are very closer to each other. To make you understand, I have drawn these two rays little bit far from each other, but actually these rays are very close to each other, because if these rays are so much far, then how can a small eye see these rays? I mean, how can these rays fall on a very small eye? Our eye is very small, right? So these two rays actually should fall on your eye. So actually I should have drawn like this. there is some little bit, actually little bit bent. There is a very small little bent and somewhere here it appears. Actually I should have drawn the diagram like this, but to make you understand I have drawn this. So actually these two rays are very closer to each other, very closer to each other. When these two rays are very closer to each other, this angle is going to be very small, I. In the same way, this refracted ray, this is also going to be r. This r is also going to be very small. So the very important thing that I am telling you is, we are assuming these two rays are para-axial rays, which means angle I, angle r are very small. When angle I and angle r are very small, when angle I and angle r are very small, sin I is equal to tan I. This you can even learn from mathematics. When angles are very small, these are equal. So sin r is equal to angle r is equal to tan r. So we can substitute, here we can substitute tan I, and here we can substitute tan r. So N2 tan I is equal to N1 tan r. What is tan I? Tan I is equal to, so this is one of the triangle. So tan I is equal to perpendicular by base. What is perpendicular? We assumed it as x. So N2 into tan I, that is x by, this is the perpendicular, this is perpendicular, this is base. We assumed it as d. This is real depth, right? We assumed it as d, which is measured from the surface. So x by d, perpendicular by base, is equal to N1 into tan r. What is tan r? Here it is r. I have already shown you in the diagram. So what is tan r? Perpendicular by base. Tan r is equal to x by, this is nothing but apparent depth. I have already told you this. This is nothing but apparent depth. So tan r is equal to x by d dash. Now N2 by N1 is equal to x cancel, d by d dash, where d is the real depth and d dash is the apparent depth, where d is the real depth and d dash is the apparent depth. So this is how we have derived this formula. Now let us go into the problems. The first problem is, this is a pond. This is a pond and there is a fish in the pond. There is a fish in the pond which is 24 centimeters away from the surface, and there is a bird flying in the air which is 36 centimeters from the surface. Now the question is, find apparent depth of fish as seen by the bird. So this is the question. Now we have only one formula here, that is N2 by N1 is equal to d by d dash. What is N2? N2 is, see, read the question properly. Find the apparent depth of fish as seen by the bird. Bird is seeing fish, right? So light ray has to come from bird towards fish. That means light ray is coming from fish towards bird. Light ray is coming from fish. That means Sorry, I forgot to give you the refractive indexes of the mediums. The refractive index of this medium is 4 by 3, and refractive index of this is A. Refractive index of A is 1. Now we have two refractive indices. What is N2 here? The light ray from where the refractive index of medium from where the light ray is coming. So from here the light ray is coming. So this must be N2. So that is equal to 4 by 3. 4 by 3 and N1. The light ray is going from here. It is going towards bird. So this is equal to 1. N1 is equal to 1. So N2 by N1 is equal to D by D dash. What is D? Real depth of the fish. What is the real depth of the fish from the surface boundary? 24 centimeters. D dash is apparent depth, which we have to find. This apparent depth we will get from this surface. Okay. Now D dash is equal to 24 into 3 by 4. 4, 6, 18 centimeters is the answer, which is the apparent depth from here. From here, the fish appears 18 centimeters. The distance between the surface boundary is, this is 18 centimeters. Fish is somewhere here. From, if you see from here. But what is the question? Find apparent depth of fish as seen by the bird. But the bird is situated here. The bird lies here. So this is 18 centimeters and this is 36 centimeters. Total 36 plus 18, which is equal to 54 centimeters. What is the actual depth as seen by the fish? 36 plus 24, right? But the apparent depth is 36 plus 18, which is equal to 54 centimeters. Now let us change this question like this. Find the apparent height. Find the apparent height of bird as seen by the fish. As seen by the fish. Find the apparent height of bird as seen by the fish. Now this fish is seeing this bird. That means light rays are coming from bird towards fish. That means light rays are coming from this medium into this medium. What is the refractive index of this medium? 1. So refractive index N2, which is the refractive index of medium where the light is coming from. So that is equal to 1. 1 by N1. What is N1? N1 is 4 by 3, where the light is going. The light is coming from bird and going to this medium where the fish is lying. So this is 4 by 3 is equal to D by D dash. What is the apparent depth? What is the real depth as seen by the fish? Real depth is calculated from the boundary. This is the real depth, 36 centimeters, or real height, you can say, whatever it is. What is it? 36 centimeters. And D dash. Now D dash is equal to 36 into 4 by 3, that is equal to 48 centimeters. You can observe this as 48 centimeters. So from here, D dash, from here the apparent height is 48 centimeters. See, the apparent depth or apparent height is larger than the real depth. That's what I have told you earlier. It depends on the cases. So 48 centimeters. But what is the question? 48 centimeters is from the boundary. What is the question? Find the apparent height of bird as seen by the fish. Fish is seeing from here, right? So this is 48 centimeters and this is 24 centimeters. 48 plus 24 is equal to 72 centimeters is the answer. And now we will move to the next question. Question number 3. Here there is a glass slab. Here there is a object. This is the object, which is 10 centimeters. and the thickness of the glass slab is 15 centimeters, and you are here 20 centimeters from this surface. Your eye is here, okay? You are seeing from here, this is eye. Now the question is, find the apparent depth of object as seen by the eye. So this is the question. In this question, the problem is there are three mediums between the eye and the object. One is air, this is air medium, this is glass, which the refractive index of glass is 1.5, and air refractive index is 1. Refractive index of air is 1. So refractive index of air, this is also 1. So here you have one medium, that is air, here you have one medium, that is glass, and here you have another medium, that is again air. So there are three mediums, and there are two refractions. Here the light ray refracts and it travels in this glass slab, and because the medium is changing, again it refracts here. So this we can say as a second surface, this we can say first surface, where the refraction is happening. This is the first surface and this is the second surface. To solve such type of questions, first we have to assume that we are seeing this object from this, we are seeing this object from here in this medium. If you are seeing this object from this medium, the light rays are coming from this object and going to this medium, okay? The light rays are coming from this object. That means the light rays are coming from this medium and going to this medium. So at first refraction, first surface or first refraction, we have formula N2 by N1 is equal to d by d dash. What is N2? N2 is 1 because light rays are coming from here. 1 by what is N1? 1.5. 1.5 refractive index of glass. What is D? D is, this is the real depth, 10. What is D dash? We are seeing from here. So D dash, we have to find D dash. So D dash is equal to 10 into 1.5, that is equal to 15 centimeters. So this 15 centimeters will be from the boundary. This is what I am always telling you, from the boundary. So from here, the object, you will see, from, if you see the object from this medium, from here, the object appears 15 centimeters from the boundary, okay? But at this surface, the real depth would be this 15 centimeters and this 15 centimeters, which is 30 centimeters. I mean, see, there is first refraction here and there is going to be second refraction. We have also learned in the combination of mirror, this is the first image formed because of this refraction. This is the image, this is the actual object, but this is the image formed because of the refraction. So this image acts as virtual object for the second refraction. This is what we have already learned while we were discussing combination of mirrors. So this image acts as virtual object. So this acts as virtual object for this surface, because for this surface the rays are coming from this object, because already one refraction has happened. So the rays are coming from this image, okay? So second refraction, you can say second surface, or at second refraction, if we apply the same formula, see, at this refraction, light ray is coming from this medium and going to this medium, because we are seeing from here, okay? Light ray is coming from this medium and going to this medium. So what is N2? N2 is 1.5 because light rays are coming from here. 1.5 by what is N1? N1 is this medium, that is 1, because light rays are going to this medium after refraction. Okay, that is equal to d by d dash. What is d? D is the real depth from this surface, because we are calculating now at second surface. We are we are in the second refraction. Already we have learned about the first refraction. Now we are here at the second refraction. So what is the real depth? Real depth is from here. This is acting as a virtual object. So 15 centimeters plus this is 15 centimeters and this is 15. That is 30 centimeters by d dash. Now d dash is equal to 30 by 1.5, which is equal to 20 centimeters. So from here the apparent depth is 20 centimeters. This is already 15. So the image of the object is somewhere here. That means apparent depth of object. The final image will be here, which is 20 centimeters from this surface. From this surface, this is 20 centimeters from this surface. But what is the question? Find the apparent depth of O as seen by the eye. Eye is here. So we have to measure this 20 plus this 20. So 20 plus 20 is equal to 40 centimeters will be the answer. If we increase the difficulty of these questions, we can also increase by taking combination of mirror and lenses. That means if we combine both reflection and refraction, we can go to JE advanced level of questions. But since the time, because of the time constraint, I am stopping this lecture here. Thank you very much.